quotient rule. Suppose we want to take the derivative of f of x over g of x. So now we have the ratio of two functions, or quotient. Let's look at how we can use the product rule to solve for this derivative using some algebra tricks. And from there, we'll derive what's called the quotient rule. So algebraically, we can rewrite this as f of x equals g of x to the negative 1. So we do that by taking this function, raising it to the 1 power, and bringing it up by making that power negative. We do this so that we can use the product rule, because to use the product rule, we have to have two things multiplied together. So from the product rule, we're going to take the derivative of the first function times the second, that's this first part, plus f of x times g prime of x. So the derivative of g of x to the negative 1 is going to be a chain rule, where z is g of x and dz dx, the derivative, is g prime of x. So that means when we use this rule, remember, we're going to have negative 1 z, which is g of x, to the negative 2, because we subtract 1 from the power, times g prime of x. So we take that derivative, and that's what's multiplied over here. Now, algebraically, we can take the first term, and we can put the g term back in the bottom by making the 1 power back into positive. From the second term, when we look at what's going on, we can pull the negative in front. We have our f of x. We have our g prime of x. But then we can take this g of x to the negative 2, and we can put it back in the denominator by making that 2 positive. So here we just had an algebraic rewrite of what we had found before. So finally, if we want to get a common denominator, we can get the common denominator of g squared if we take the first function and we multiply the top and the bottom by g of x. Doing so means that in the numerator, we'll have f prime of x times g of x, and in the denominator, we'll have g of x squared. Putting that all together, we end up with something that looks like this. F prime of x times g of x minus f of x times g prime of x, all divided by g of x squared. And this is what we call the quotient rule. So the quotient rule is a way that we can take the derivative of quotients, one function over another one, without having to turn them all into product rules. When we turn them into product rules, we often will have to do chain rules within there, and so it's often easier to use this quotient rule formula to find our derivative. Let's try some examples. Example 1. Use the quotient rule to find the derivative of f of x equals e to the x over x to the 5th. We did this problem before, but we used a product rule. Now we're going to try it with the quotient rule. One of the things that you need to know about the quotient rule is that here, order is very important because we're talking about subtraction and division, which means when we pick our f and our g, order matters. Your f is always going to be the function on top, and your g is always going to be the function on the bottom. So here, my f is going to be e to the x, and my g is going to be x to the 5th. Now I need to find each of their respective derivatives. The derivative of e to the x is e to the x, and the derivative of x to the 5th is 5x to the 4th. So now I need to take those terms and I need to plug them into my quotient rule. My quotient rule said that I'm going to do f prime times g, so e to the x times x to the 5th, minus f times g prime, so minus e to the x times 5x to the 4th. All of that divided by g squared, so x to the 5th squared. For now, we're not going to worry about simplifying too much. In later chapters, we'll have to simplify because we'll be using derivatives to solve for various things. But for now, we want to get the structure down. So we can leave our first derivative like this. Let's try another. Example 2. Use the quotient rule to find the derivative of f of x equals sine x over the natural log of x. So again, my f is always the function on top, which here is sine of x. My g is always the function on the bottom, which is the natural log of x. Now, taking each of their respective derivatives, the derivative of sine is cosine, and the derivative of the natural log of x is 1 over x. Now I need to plug that into my quotient rule formula. So I'm going to do f prime times g. So cosine of x times ln of x minus f times g prime. So sine of x times 1 over x, all divided by g squared. So the natural log of x squared. So my first derivative using the quotient rule looks like this. Let's try another. Example 3. Find the equation of the tangent line to f of x equals the natural log of x plus 2 over x cubed at x equals 1. So for the equation of a tangent line, I need f of 1 and f prime of 1 to be able to find my equation. F of 1 means I'm going to plug 1 into the original function. So that means I'm going to have the natural log of 1 plus 2 all divided by 1 cubed. Now the natural log of 1 is going to give me 0. 0 plus 2 is 2, divided by 1 gives me a value of 2. So that means that the point where I'm interested in looking, where my tangent line is going to touch, is the point 1, 2. Now, I also need the derivative at 1. So to find the derivative, I'm going to need to use a quotient rule. So, if I come up here, my f is the natural log of x plus 2. My g is x cubed. And now I need to find each of their respective derivatives. So the derivative of the natural log of x is 1 over x. The derivative of 2 is 0 because it's a constant. The derivative of x cubed is 3x squared. So now again, I need to plug this into my quotient rule formula. So I'm going to do f prime times g, so 1 over x times x cubed minus f times g prime, so the natural log of x plus 2 times 3x squared, all divided by g squared. So now I need to plug in a 1 everywhere. I'm going to do this really, really carefully, but I'm going to crunch some numbers as I go. So I have 1 over 1 times 1 cubed. That gives me 1. Minus, now in my parentheses, the natural log of 1 is 0. 0 plus 2 is 2 times 3 times 1 squared, which is 3. All divided by 1 cubed squared. So 1 to any power is going to be 1. So here I multiply the 3 and the 2 to give me 6. So in the numerator, I have 1 minus 6, which is negative 5 divided by 1. So all in all, I end up with negative 5. So f prime of 1 is negative 5. And remember, the derivative at a point is going to tell me the slope of my tangent line. So now I have y equals negative 5x plus b. I'm going to plug in my point, so 2 for y and 1 for x plus b. So I'm going to add the 5 over, which is going to give me that b has to equal 7. So finally, the equation of my line is y equals negative 5x plus 7. So that's the equation of my tangent line. And here again, I had to use the quotient rule in order to find the slope. Example 4. Find the first and second derivative of f of x equals x to the fourth over sine x. Second derivatives tend to get really complicated really fast when we have quotients. So we're going to have to be extra careful here with all of our steps. So to begin with, let's find the first derivative. So my top function is x to the fourth, which is my f, and my bottom function is sine x, which is my g. I need to find each of their respective derivatives. The derivative of x to the fourth is 4x cubed. The derivative of sine x is cosine x. So my first derivative, I'm going to have f prime times g. So 4x cubed times sine x minus f times g prime. So x to the 4th times cosine x. All of that divided by g squared. So sine x squared. So my first derivative wasn't so bad. I was able to easily find the derivatives I needed and plug them into the formula. However, looking at this, you might start to get a sense that the second derivative is going to be a little more complicated. So again, I need to take the derivative of the first derivative. So my f is going to be the numerator. So here, my f is 4x cubed times sine x minus x to the 4th cosine x. And from there, I need to find my derivative. And then my g is going to be sine of x squared. And I need to find my g prime. So let's start by f prime. So notice that both of the terms here are going to require a product rule. So the first term, I have 4x cubed times sine x. So for my product rule, my f is 4x cubed and my g is sine x. Finding each of their respective derivatives, I get 12x squared and cosine x. So now I'm going to do f prime times g plus f times g prime. So that gives me 12x squared times sine of x plus f times g prime is 4x cubed times cosine x. But that was just the derivative of my first term. From that, I have to subtract off the derivative of the second term from x to the 4th times cosine x. So again, I'm going to have to do another product rule. So my f is x to the 4th, and my g is cosine x. My f prime is 4x cubed, and my g prime is negative sine x. So f prime times g is 4x cubed times cosine x. Now minus, because of the minus from the sine, minus x to the 4th sine x. So remember, my first derivative is this whole entire term. So now I also need to find g prime of x. Now to go from sine of x squared, and in order to take the derivative, I'm going to have to use a substitution here because I have to do a chain rule. So here I'm going to have z equals sine x, and dz dx is the derivative of sine, which is cosine. So remember, when you have parentheses to a power, the power comes down, your z stays the same, and you subtract 1 from the power. But then we have to multiply that by dz dx. So times cosine x. So now we have all the pieces we need to plug in to get our final derivative. So let's plug everything in very, very, very carefully. So again, in the top, we're going to have f prime times g minus f times g prime. So what I want you to notice about f prime is that I have a 4x cubed cosine x and a minus 4x cubed cosine x. So those are going to cancel. I'm going to use a lot of parentheses here. So I have 12x squared sine x. Now my 4x cubed cosine x terms cancel. And then this minus is also going to go to this negative term here. So that's going to cancel to give me plus x to the 4th sine x. So that's my f prime times, let me draw a line here, times g, which is sine x squared, minus, now I have to do f times g prime. So I'm going to use parentheses again because there's a whole bunch of terms. So 4x cubed sine x minus x to the fourth cos x. There's my f times g prime. So times 2 sine x times cosine x. All of that divided by g squared. So sine x squared squared. So my second derivative is really super long, right? But as long as you're careful, hopefully you won't lose any negatives or any terms. We're not going to try to simplify this because it's way too long. But again, if we go term by term and we're really careful, hopefully we don't lose anything along the way, and we're able to use the quotient rule to find our second derivative. Example 5. Find the derivative of f of x equals sine of x cubed plus 2x minus 1 over e to the 5x cubed. So this is another instance where we need to be extra careful because here our derivatives are going to involve chain rules within the quotient rule. So again, my f is always the function on top. So sine of x cubed plus 2x minus 1, and my g is e to the 5x cubed. Now, to find each of their respective derivatives, I'm going to have to do some chain rule substitution here. So for the first term, my z will be x cubed plus 2x minus 1, and my dz dx is going to be 3x squared plus 2. So remember, when you take the derivative of sine, you get cosine of z, which is the same thing. And then we have to multiply by dz dx. And I'm going to use parentheses because there's more than one term. Now over here on my e front, my z substitution, my z will be the power of e, so 5x cubed. And my dz dx, the derivative of that will be 15x squared. And with e's, the derivative is e to the z, so e to the 5x cubed, times dz dx, so times 15x squared. So now I have all my pieces that I need to find my derivative. Again, I'm going to try to be extra careful when I plug everything in. So here I'm going to start off by doing f prime times g. So cosine of x cubed plus 2x minus 1 times 3x squared plus 2. That's my f prime times g, which is e to the 5x cubed, minus f times g prime. So sine of x cubed plus 2x minus 1. That's my f times g prime, which is e to the 5x cubed times 15x squared, all divided by g squared. So we have e to the 5x cubed squared. So my derivative, with all my chain rules in there, ends up looking like this. So again, you just have to try to be extra careful, not lose any negatives, things of that sort, and plug everything in very carefully, and you should be able to find the derivative of quotients that involve chain rules.